Hello friends, welcome to our channel Knowledge Amplifier. So in my previous video, I have already explained the mathematical intuition behind principal component analysis, which is one of the very popular and frequently used dimensionality reduction technique in machine learning and data science domain. And now in my this particular video, I am going to discuss one practice question on the same topic. Okay, so in my previous video I have written this particular expression. The code is very simple. PCA of your data, if you pass, you will be getting this much output parameters. Okay, and among all these output parameter in score, what is present? The observation column wise present, from which we can take our required number of columns, okay, which is basically representing the data after converting to lower dimensional space from higher dimensional space. Okay, and the explained, this variable also plays a very important role, as I have discussed earlier. What is this explained variable? This basically indicates how much one particular principal component explains, how much percentage. Okay, if you just check here what is written in the documentation, also returns explained the percentage of total variance explained by each principal component. Okay, so explained is the column vector, we can say, where each element is explaining, each principal component is having how much percentage of total variance. Okay, because if you recall our primary video where we have discussed the intuition of PCA, I have told you we have to map to lower dimensional data such that variance become maximum, right? So maximum variance parts information we can get from the explained data. Okay, and based on this we are going to solve one particular problem statement. Okay, so practice question on PCA, and the question is: create a script to compute the number of feature dimensions n needed to represent at least 99.9% of the variance in the feature set of the human activity dataset. Okay, so why we are going to solve this particular problem statement? First, let us try to understand that. Now you are using PCA to convert your high dimensional data to lower dimension, right? Now we check the explained variable, okay, and then whatever variable values we are getting, based on that top 2 or 3 principal components we take, like we have used earlier. Also in my previous video I have shown you first 2 principal components was explaining majority part, more than 50%. That's why we have reduced the dimension to only 2 PCA, okay, 2 principal components, right? Now here how many principal components needed? Okay, that depends on how much percentage variance you want overall. Okay, suppose I want to capture 99.9% variance. Okay, that time how much components, principal components you need to take? To determine that, we are solving this particular use case. Okay, so what we'll be doing, we will be first loading human activity dataset. So here very simple, CLC clear all, close all warning of load human activity.mat. Okay, if I just run this particular code, here you can see many variables will appear in the workspace, and in this feed variable my human activity data is present. You can clearly understand that this is a very high dimensional data. Now we are taking the d equal to fit. Okay, so now my this particular fit data is present in d variable, and we are applying PCA on that. Okay, so let me run this particular part, right? And then if I just show you explained variable, see here what we are getting. See, first principal component is capturing 95% of variance, then second one 2.98, next one 0.95, and further it is decreasing, right? Now the question is asked that create a script to compute number of feature dimension needed in, that is n value, how many feature dimension needed to represent at least 99.9%. Okay, so first principal component 95.47, second one 2.98, so 95.47 plus 2.98, right? 97 point something. Like this we will add one more, we will add until at least 99.9% it can explain. Okay, so what we can do here, you can clearly understand that we can first take cumulative sum. Okay, and then we can apply our logic. So what I am doing, M is equal to come sum explained. Okay, I am taking the explained output parameter, which is basically storing each principal component is uh, capturing how much percentage of variance. Okay, and then I am writing ms equal to come sum explained. Okay, so let me just clear this command window and run this. Okay, now if I show you ms, see at the end obviously you will be getting 100% if you take all the principal components, because if you take 100% then there is nothing happening actually. That means you can take original data also. Here we are reducing the dimension, that means obviously some part of the variance will go, not 100% will be getting. So here you can see if you take only first principal component, only 95.47% of variance you will be getting. Then if you take first two, then 98.46 you will be getting. First three, 99.41 something you will be getting. First four, 99.87, like that you will be getting. Now at least our requirement is 99.9. So what we will be doing? We will be using one for loop. So what we are doing here, we are defining n equal to 0, and then for I equal to 1 colon length of ms, that is we are iterating in this particular cumulative sum variable ms. If ms of I greater than 99.9, that means at least we have crossed 99.9% capturing of our total variance. We will update the n value n equal to I, and we record the at least how many number of principal components we require, not at max, right? So as soon as this condition will be satisfied, we will update the n value and will break this for loop. That's all. And in the n variable, how many principal components are required to capture at least 99.9% of our total variance will be stored. Okay, control A, evaluate selection, and if I write n and hit enter, see I'll be getting 5, right? So at least 5 principal components are required to take 99.9% of the variance in the feature set of the human activity dataset, right? So this is the importance of the explain variable, which is denoting each principal component has captured how much variance of a total dataset, and it is in percentage. Okay, out of 100%, how much it is taking. Now, how many principal components are required for a particular case study? If you need to know, then how much variance you want to capture, you just put that here and calculate the n value. That's all. The same code I'll be posting in the description box or in the comment section. If you want, you can go through that. Thank you for watching.